Okay, so here are some of our objective. Number one, to know what is recursive and common complexity classes of an algorithm. So I think it's part of your assignment to know what are the common complexity classes, which is actually we already started to have this common complexity classes when we have the iterative algorithm, but this time we really have to know exactly what are they. Then number two, to compare the disadvantages and advantages of using recursion in coding. So probably later on, as we go along with our program implementation, you will know exactly what would be the advantages and disadvantages. And probably I will also cite few things of these disadvantages and advantages of using recursion. Then number three, compare and contrast recursive and iterative algorithm analysis. So we will try to look into how can we or when we there is a snippet of code, how are we going to find the T of n, no, the time complexity. Then next is to prove how to define and solve recurrence relation. So since we are in the recursive analysis of algorithms, we will be solving recurrence relations. And finally, to apply recursion in real life program. So after this discussion, probably we will might proceed to the application of recursion. Okay. So let's start with, so what is a recursive algorithm? So it is an algorithm that finds a solution to a given problem by reducing to smaller version of itself. So it has one or more base cases, and it could be implemented using recursive method. And probably along the way, you will know what is it. So in a recursive method, it is said that method that calls itself. So probably it is easy to use this particular algorithm in during implementation. But what is the thing that might be hard is how to determine it during the recursion, no? The recurrence relations afterwards. And the base case, it is a case if in recursive definition in which the solution is obtained directly, and then we will stop the recursion. So this would be the illustration of the recursive algorithm. So there is the work there. So na siya recursion and na siya base case na method. So in that case, what would be the advantages and disadvantages of the recursion? So number one, ang advantage niya ay simplicity, sorry, it's simplicity of code ha. Sa'yo po. And then number two is easy to understand. Yeah, because you just call the method by itself. So mas dali siya masabtan, and it's easy to you to code for it, for that particular method. Pero when you compare it to iterative, iterative is very hard in coding, but it's easy to find the time complexity. You can compare it later on. Then the disadvantage for recursion, since you have to call the method by itself, so there is memory storage problem. And then once sige kag balik-balik og tawag, ang speed niya mo low siya. And then possibly there is a redundant of work. Manay disadvantage for recursion. So is this your answer in the common complexity classes? Is this your answer? So there are how many common complexity classes? There are 8, no? So constant is big O of 1. The logarithmic is big O of log n. Then linear is big O of n. Then the n log n is big O of n log n. Then quadratic, it's big O of n squared. Okay? Then the cubic, of course, big O of n cubed. And then the exponent would be 2, or exponential. It's big O of 2 to the power n. And factorial, it's big O of n squared. So in this case, we try to put a certain value on how we can have these complexity classes. So probably might be switching to my what we call this camera for further explanation on the time complexity classes. Wait, I might change my wait. Stop presenting. Huh? What happened? Wait, no. Okay, so I will be presenting my camera. Okay, so for time complexity classes, for example, sige, let's try to kindly answer me, or you may answer using the chat box, or you can open your mic for answering this. So can you see my screen there, the camera? Hi.
Yes, white miss.
White miss.
White only.
White screen.
Wait lang. What happened? White. Is there any other, any text?
No miss.
No.
None.
Wait lang. Na or wala?
Wala miss.
Oh, okay. Madali lang. Okay. I will be presenting by the use of the whole window na lang instead. Ay. Window. One more. This time? Okay. Aron na may makita. Okay. Sige. So, we will go through in log in, no? So, log in. And then, how are we going to determine the n? Okay. So, in log n, so it's a 1, 2, 3, 4, something like that. So, in log n, usually, what would be the base? The base is, again, you can answer through the chat box, or you can on your mic and answer it. So, our base is 2. So, kung log n, this is 2. Ang 1, if your log n ng 1, the n is 2. Kung 2, pila man? Pila kung 2? 2 to the power, log n of 2, pila niya? Ang iyang n kay 2, punsa man? That is?
4 miss.
4. Then sunod?
8.
Pila? 8, correct. Kung 4,
16
16, correct. Okay, and so on and so forth, no? So I think you know that one. So see, for example, I will draw it. So you have there, you have there the n. So I think you know it, no? Unsa to, constant. Hindi pa ganito, kay namdo mo? Tawag doon sunod. Logarithmic. Tapos, after that would be? Linear. Dayon, after that, unsa?
N log
n. N log n. Then after sa n log n, unsa to?
Quadratic.
Correct, quadratic. After that, Kuan ko kay my camera is in the other
Cubic.
side. Okay, cubic. And then,
Exponential.
okay, exponential. After that, what would we?
Factorial.
Factorial. 8 na ba? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Ito lang ikan. So let's try to recall our mathematics here. No? So see for example, movable mo ganitong camera. So your n here is 2, then 4, then 8, then let's say for example 1024. Ang lang siya. So in your constant, kung constant siya, the value there is 1. Di ba? Big of 1. So 1 ra gyud na siya tanan. 1. Kung logarithmic, unsa man to kung 2? Unsa man to kung 2? This is, kung 2 gani siya, unsa ganito? Kanang mo? 1. Tama. Kung 4, unsa to?
2,
2. Kung 8,
3, miss.
3. Correct. Kung 1024, pila man ang 1024? That is, pila man ang 1024? That is 2 to the power?
10, miss.
10. Tama. Tama, Brian. Kaya in linear, ansa tong linear? Ay, wala pa detay. Kulangan detag n, no? Sige, arin lang ako ibutang ang n sa ubos. Kaya ansam gani si n gani? That is the linear, mo na ng linear. Linear din, this is n, no? Kani mo ni ang log n. Tama? Okay, so sige. So kung n lang na siya, that would be 2, 4, 8, 1024. Ito na yung camera na skilled eh. Okay, how about n log n? How are you going to do it? Diba? N log n. So, unsaon ganun siya? N log n. So, it would be 2, the log n is 1, right? Kani during a part. So, n times 2 is pila? Rather, log n 1 times 2 pila? 2.
2.
Sunod, pila man?
8.
8,
8. Tama. Okay, very good. How about this?
24.
24. Sakto, Dolera. How about this one? How about this?
10 to 40.
Okay,
10,000.
10,240. You times man ana niya. How about in quadratic? Quadratic na ba? So, unsa man ganang quadratic, that is, unsa to? N of n squared ba? N squared. This is n cube. This is 2 to the n, and then this is n factorial. Tama? Okay. So, for quadratic, n squared, pila atong n? 2. So, pila man na siya? Pila?
4,
4.
4.
4.
This one? Yes, correct. This one?
16,
16. Tama. This one?
64.
64.
64. Diri kay ato na lang yung 1024 to the power 2. Mo ba? Pwede ra gud na ma-solve, di ba? It's 2048. Sakto. Dili squared man. So, murag dako-dako na siya. How about for cube? Unsa man ni diri?
8.
For cube. 8. Diri? Hala.
64.
64. Yes, correct. How about this one?
512.
512 or 512, and then probably we can have it 1024 to the power 3. Okay. How about in exponential? Sige, how about this one? I think you know this one, 2 to the power n gihapon, no? So 4. This one? Saan man ni?
16,
16, correct. This one? Pila naman eh? 2 to the power 8?
256.
256. And probably this is 2 to the power of 1024. Okay, how about in factorial? This one is
2, miss.
2.
2.
How about this one? 4 times 3 times 2.
24, miss.
24. And then, kanitaas naman eh. So, we'll say 8 factorial and then 1024 factorial. So, these are actually how are we going to determine the common complexity classes. But what we're going to prove later in the recursion is this one. Kani mga log n, mga n squared in cube depending on the given. Okay? So, going back to our presentation. Where is that? Around there. Here. Okay? So, from these common complexity classes, we will try to prove later on with the different codes given. So, for this, we will have the example. So, we can recall the factorial function. So, the factorial function is n factorial is equals to 1 if n is equals to 1, or n times n minus 1 factorial if n is greater than 1. Okay, then we will try to compare the iterative and recursive algorithm. So I think if we have to put this on a move siya. So in iterative algorithm, if you remember, I will say in our example, sum equals 1 or sum equals 0. So in this case, I'm using the factorial na given. So it would be factor equals 1. So when you count that one, that is 1. Okay? And then for n I equals 0, I less than or equals to n, then I plus plus. So you have to, in iterative, as we recall, so this is how we are going to put a label. And then n, this is n, and then this is another n. So that's why when you derive this particular code in iterative or iteration, it's 4n plus 3. Now, how are we going to convert that into a recursion? So in a recursion, inani siyang mahitabo. So it would be n factor, and then you pass an n. And then if n is equals 0, return 1. So this one, this is our base. And this would be here, would be the method that call itself. So it would be the method that call itself. So we will try to prove, I think, there. No? So 0 factorial is always equals to 1. So then it is katong naasa ibabaw nga gi-recall na to with the factorial. So how are we going to do with the analysis on that? So how many multiplication are m of n or t of n? But since we are using multiplication, so munang m of n, does factorial perform? So you have it in there in the analysis. So when n is equals to 1, we don't perform any. Or when n is equals to 0, we don't perform any. So otherwise, we perform 1. Plus, however, many multiplication we perform in the recursive call. So it would be in the else part, so you will have factorial n minus 1. So kung balikon later nato sa ubos nyo, sa ubos niya na lang. So this can be expressed as a formula similar to the definition of n factorial, like that. So if your n is equals to 1, so you will say n is plus m minus 1. So probably we're using the m later on, we'll be using the t as the time complexity goes. So this is known as the recurrence relation. And what is a recurrence relation, by the way? So it is a sequence of a sub n, okay, which it is an equation that expresses a sub n in terms of one or more of the previous term in the sequence. So manang a sub 0, a sub 1, and so on and so forth. In which for all integer, n is greater than or equals to n sub 0, where n sub 0 is a non-negative integer. No? So the sequence is called the solution of the recurrence relation if its terms satisfy the recurrence relation. So in that case, it has shown that this part there is the base case, and this one is kanisha, munang gitawag niya, the function being called but itself. So it would be what we called as the recursion na nahitabo when the recursive algorithm is being used. So in a recurrence relation, try to take a look on that. So it would be based on this particular code, kaninga code. So if we try to take a look on that, this is theta of 1. Kanidering apart ka ng return 1. Diba? Katong naa sa analysis. So this is theta of 1. And this part here is, it would be, that would be, we are using the t now. So t n minus 1. So when we consider the recurrence relation, it would be the theta, our n, or our t sub 0, or t of n is big theta of n plus the t of n minus 1. Okay? So this is the thing that we're going to solve later on, and I might be giving you another example to solve afterwards. So your t of 0 is equals to 1, so you'll have it, the formula based on this given here, kani apart. So this is theta of 1, and then this is n, pero n, or it would be, since there is no ano man siya, so it would be the factor of n minus 1, so which is t of n minus 1. So your t of n is 1 man siya, so mga nang 1 plus t of n minus 1. Okay, now, in the case like this, how did the recurrence relation goes? So it would be, di ba, I think you know how to call that one, no? Mubalik siya, o tawag, mutuyok siya, no? Recurrence relation. So, first loop niya, kani. So, the same siya, pero mo increase ng t of n, mahimo na ng 2. So, mo ng 1 plus t n minus 2. So, next kay 1 plus 1 equals 2 plus t of n minus 2. Ina ko ha kung wala mo nakasabot ha. Na. And then, kung dili pa kakakita og pattern, you go ahead. No? Kanama siya gitawag og pattern. So, in that case, you might have to expand again based on this. So, in other words, you will call the method again. So, it is considered as recurrence relation. So, it would be 1 plus, we increase na pod c, instead of 2, we increase na pod siya to 3. And the third, kani siya is the first na kanang pagtawag sa iyang recursion nga method. And then this one is the second, pero mo increase ni siya during the theta. Yes, digamo? Na-question?
Wala, miss. Wala.
Okay. Sige. So after that, so again, it will be 1 plus t of n minus 3. So it would be 2 plus 1 equals 3, and then you just affix the t of n minus 3. So kung imo makita, no, tanawa, try to take a look on this. So 1, then 1, then 2, then 2, then 3, then 3. This, pwede pa na ko siya ipadayon. Yes, you can padayon, but as you can see, there is already a pattern. Na kay makitang pattern. So that is why you have to put a generalization, like in this side. So you will say in general, so this particular number here, you may use a particular variable. Para imo siya i-compute what would be the time complexity for that. No? So you will prove kung big O of whatever na siya. Big O of n log n, big O of n, big O of log n, no? Katong atong kuan nga time complexity classes, common time complexity. So, in that case, so as you can see, based on this, so the 3 here, ang kaning 3, imo siyang gilisag I. No? Plus t of n, diba pareha man siya 3, 3. So n minus I. Then after that, you will say, as I approaches n. Na si I daw mo approach to n. So therefore, you will say t of n is equals to n plus t of n minus n. Okay? And then you will say n plus t of n minus n is 0, so which is n plus 1. Okay, the t of 0 there is 1. Or approximately, approximately the value, which is the most significant there, is the n. So that's why you will say big O of n. Question. Nasabtan ka? Hi. Do you have any question? Tarungoy, Yongko, Dayuday, do you have any clarification so far? Wala question? Okay, very good. So let's proceed with another example. Kani siya, kaya na siya 4. Kung tanaanin nimo diri sa taas, wala siya 4 na, simple code. Here, like sa inyong exam, ningon ko ninyo, and ang outer, good, it's the summation. So, ang uban ninyo naka-answer, ang uban kay, sakto na ang tang label, giusab, lahi lang ilang gi-interpret nga n nga akong giingon. It is still n squared, pero ang yan sa summation nga gimina ko, it's still n. Okay, so we will be using another example. So this time, we will have one loop, no? Loop na siya. So it would be, na naman siya isa ka-loop, di ba? It would be n plus t n minus 1. So again, our base is big theta of n, big theta of 1. So from there, so nanapod ko i-solve. So this is another thing. Why? Our t of n, our t of kanang 1 there is 1. Then 1 times n is n, right? Sakto ba?
Yes, miss.
Correct. Sige, thank you, Dayuday. How about others? Or n is so ito ka na, yung numerical coefficient is 1, tama? Or 1 times n is n, rather. Anak. So, as you can see now, it would be a different thing. Okay, based on this. And later, ako good is what happen, inyong masabtan furthermore. So, you have there, n plus t of n minus 1. So, in that case, when we prove this, it would be the n, and then apa siya minus 1. Okay? So, it would be n minus 1. Miss, nga naman to sa ibabaw. Constant na itong value sa una, di ba? 1 raman to siya. Karoon na siya n. Okay? Ato timanan ha, it would be, pwede niya siya screenshot, but anyway, you can still view this one after our discussion because I record this particular discussion para you to review pag yun ninyo furthermore. So in that case, so you have seen there, so it would be n minus 1 plus t of n minus 2. And then you will add, so n plus n equals 2n minus 1 plus t of n minus 2. Imo lang i-rewrite na siya. Sunod. Diba, in next na loop niya, in next call niya, it would be n minus 2 na pod siya. Misa nang wala na nag-2 dira. That would be the first, kani siya kay n pa man na siya, di ba? So, next niya, it would be 0, then 1, then 2, no? So, it would be n minus 2 plus t of n minus 3. And then you add again, no? So, 2n plus n is 3n, and then minus 1 of 2, it would be negative 3. Negative 1 of ano, it would not be positive, no? Kaya kuan man na siya. So, it would be negative 3. So, then, after that, imo na sad siyang gitawag recursively. So, mo na sad na siya, ni 4, and so on and so forth. Hantod, Miss, pwede ba ko diri lang kukutob sa 4n? Yes, pwede. Pwede ra. Kung makakita na ka sa iyahang pattern, as I have said. But sige, we will end until here. So 5n minus 10. Then t of n minus 5. Okay? Then after that, try to take a look on that. So this one here is actually same as this. O na siya, kung imo matanaw. So it would be n plus n minus 1, n minus 2, di ba? N nagsugod. Then n minus 1, n minus 2 to until mahabot siya 1. Which is if you try to recall that one, the summation of n as I equals 0, or rather summation of n to I, where I is equals 0, is approximately equals to n squared over 2. And that n squared over 2 is log 2n, which is equals to log 2n to the k. Okay, unsa gali ni siya kani nga part diri? Probably naani siya sa katong log n or log b to the k, like that, or depende kay naman ko ni siya representation unsa ni siya. Usually this would be b, ani the value, and then this would be the n. So furthermore, ato pa nang i-explain further kana nga part later sa log of n para masabtan ninyo. Sige, dili na lang na nako is at work. Dili na lang na nako is at work. I will be giving you another example. Or kaya ninyo is at work. Sa yun naman eh. Kila man imong theta ani? Theta of 1. Theta of 1 pila? 1. Correct? Then this is, so it would be, wala man siya n, so it would be 1 plus, unsa? T of n over 2. Kaya ninyong isolve?
Dili, miss.
Dili pa. So sige, let's try to solve that one. Mobalhin ko sa camera. Paki kanang screenshots para makita ninyo kung unsa ang atong gi-solve na code. Na screenshot na?
Done.
Okay, done. Actually, sige, dalhin ko sa camera. Stop sharing. Kung makasunod ha, kindly ask lang good questions and clarifications. Okay. Okay. Ay, sorry. So, unsa gani natuto pag-solve? Wait lang. Mayroon akong camera. Okay, this is just an example for that's negative code. So in that case, saan man to? Your t of 1 is equals to, sorry, where is it? Ayan. Can you see my, can you see my,
Yes, miss.
okay. So your t of n is equals to, t of 1 is 1, no? So in that case, you will say t of n is equals to 1 plus, what is it? T of n over 2. Kindly try to take a look on your code. Now, if you try to put it in this way, it would be 2 to the power 1 siya, kana siya by default. So once it would be called using the recurrence relation, this will become 1 plus, kani if you try to call this 1, ano nga part. So it would be, mahimo na sa t of n 2 to the power, ila? 2 to the power? Kung gani 1, ang sisunod?
2.
2. Tama. Okay? So therefore, 1 plus 1 equals 2 plus t of n 2 to the power 2. Okay? So, kaya ba o dili pa? Kaya kung kaya na, pwede na kamuhunong diya. Or let's have one more. So we'll have that 1 plus t of n. Unsay sunod sa 2? 2 to the power?
3.
3. So 2 plus 1 equals 3 plus t of n 2 to the power 3. Or ganahan ba ka mo padayon? Or pwede na lang kadiha kutob? So if the case nga ganahan ka mo padayon, so it would still be 1 plus t of n 2 to the power 4. And then it would be equals to 4 plus t of n 2 to the power 4. So kung yung makita, there is already a pattern. No, na siya pattern. So unsaon man na ron siya? Ay, sorry. Ana. O sige. Anyway, you can review man this one in the koan later on. So you will say in general, kuyog na si general ha. Kato ka ganina kay wala ra to kay kuan raman to siya katong summation of I to n where I is equals 0, no? So in that case, you'll say in general, you can replace it with a variable. Kani siya, pwede na nimo i-replace an of variable. So you will say I plus t of, saan man, n 2 to the I. Sakto? Okay? So based on this, kanilang imong tanawon, it would be I, and then it would be kanimahimong I, so 2 to the I. So that is why you will say, in general, I is equals to T n over 2 to the I. Okay pa? Ha? And then you will say, assume. Mag-assume ta diri ha. Assume that n is equals to 2 to the k, and then n is a power of 2 or 2 nga number kana. Okay? And then you will say 2 as I approaches k. So, sige ingon. Assume that n is equals 2 to the k. N is a power of 2 as I approaches k. So, saan naman ni nato ron pag-replace ani based on this? Saan? This na akong color. Blue. Kaya pa? Sige, atong i-kuan ha, i-replace na siya. So, as I approaches k, so your t of n is equals to, so your t of n, ayun siya, as I approaches k. So this one, it would be k, tama? Plus t of n, sorry, wala na. T of, unsa man? Unsa ganito? Tubalikon og suwat ha, para di kay hugaw. T of n is equals to k, si I, as I approaches k. So k plus t. Unsa man to si n? N?
2 to the power of k.
Okay. So it would be 2 to the power k. N is a power of 2 man. So 2 to the power ano. So it would be, unsa to si I? Unsa to si I? Unsa to si I?
Approaches.
2 to the power of k.
K. So mahimo siyang 2 to the power k. Bisan saan na to pag ano, saan na to nga inana ang mahitabo. You have to eliminate man good na dapat you try to look for unsa ang ihang t of n afterwards. So kana parehaani. So from this one, so mo nang ingon siya n is equal to the k. Pwede ra ng n is a power, wala ning n is a power of 2. Then you will say as I approaches k, so si I mahimong k. So mo nang you replace I with k and 2 to the k, and then it would be 2 to the k sa babaw. Okay? Naka-follow pa? So, unsa may mahitabo? This would be equals to k plus T, kanya cancel man ano? Correct? So, unsa man na gani siya? 1. And then, K plus 1. Na siya. And then, what is K? Daw na po. Kinsa man daw si K. Ato nilang ning iput sa atong mind, ha? Si K there is log 2n. So, in that case, you'll say log 2n plus 1, no? Plus 1. Or approximately equals of big O of log 2n. Okay, sa taas-taas yung solution compare sa usa. Question. Sige, maghatag kog usa ka lahi na sad na problem. Unsa to ganina? Unsa ganito ganina sa example? N minus 1, no? So remember mo ato, ako sa stop. Stop sharing. Sige, I might be changing few from the then kamo daw try og solve. I'll give you 10 minutes to solve. Pag di makaya, we will solve after all. Wait lang. Where is that? Okay. Sige. Kanina example, kana ganing n minus 1, i-list di og n over 2. So instead, n plus t of n divided by 2. Sige daw, I'll give you 10 minutes to solve for that. Then ako na ibutang asset work sa inyong LMS. Bahalag mo sayop, correct or wrong, bahata lang daw, and then we'll solve after. Inyo nang gi-kan. Ako stop sharing ha, inyo nang gi-screenshot. Sige, then stop sad na ko ang recording para nag-answer pa mo.